Welcome to the coding challenge. In this video, we will be solving the problem Arithmetic Slices II subsequence. The problem statement is, given an integer array nums, return the number of all arithmetic sequences of nums. A sequence of numbers is called arithmetic if it consists of at least three elements and if the difference between any two consecutive elements is the same. So if you look at example number 1, we have 1, 3, 5, 7 and 9. The difference between each consecutive number is 2. That's why we can call it a arithmetic subsequence. The second example is 7, 7, 7, 7. The difference is 0, so definitely it counts as a valid arithmetic subsequence. We need to find out how many possible combinations we can make out of the given nums array. In the example number 1, we are given 2, 4, 6, 8 and 10. Based on this input, we can make a total of 7 combinations. And here are the list of all the combinations. This is a hard problem on LeetCode, so definitely it would take some time to understand the concept. I will try my best to make it as simple as possible. So without wasting any time, let's switch to the whiteboard and start discussing the solution. Before we dive into the solution directly, I want to highlight or talk about few of the concepts that we will be using extensively. When we have two numbers, we cannot say it is an arithmetic subsequence because of two conditions. First is we need to have three elements and the difference between all the consecutive elements needs to be the same. So here, because we don't have enough elements in the sequence, it is not an arithmetic subsequence. If I look at the difference between 3 and 5, my difference is 2. If I were to add another number, let's say 7, now it could be a arithmetic subsequence. We have to run it through our rules. We have a minimum of 3 numbers, yes. The difference between consecutive numbers is the same, which is 2. So this becomes or this qualifies to be an arithmetic subsequence. Now, if I were to find out the number of pairs that I can build using these three numbers, it will be 3, 5, 3, 5, 3, 7, and then 5, 7, and the last will be 3, 5, and 7. At 3, I cannot build any pairs because there is nothing before it. The number of pairs will be 0. At 5, I can build one pair, 3 and 5. And at 7, I can build one pair with 3 and 7, one pair with 5 and 7, and one pair with 3, 5, and 7. I can also calculate the number of pairs using a formula. When I am at 3, I could look or run a pointer against all the numbers before it and do a combination. Before 3 there is nothing, so there is going to be always 0 here. With 5, I will take all the pairs that were built before me, so I can run a pointer against all the numbers before it. The only number is 3. Only 3 has 0 pairs with it, so I cannot do anything. So I will take this and increment it by 1 because I'm adding 5, so which will make it 1. So I can only make one pair out of it. Now when I'm incrementing my pointer and pointing to 7, and then I will check it with all the values before it. So when I'm at 7, I will check 1 with 3. So how many pairs are there with 3? It's 0. 0 plus 1 will give me 1. Then I will increment my counter to point to 5. 5 already have one pair, so I will take that and increment it by 1, which will give me 2. So my total number of pairs is going to be 3. 1 plus 2 is 3. This is what we will be extensively using in our solution. Now let's switch to our problem statement and understand how this can be used. I will be using this as our problem. Earlier, we were only trying to find out the number of pairs that we could build based on all the elements in the array. But here, we will extend it to find out the pairs based on the difference between two numbers. What I mean by that is we will be comparing the combination between every two number, and whatever the difference that we get is going to be our anchor to find out if the pair is valid. The reason is we need to build an arithmetic subsequence where the difference between each consecutive numbers is the same. So we need to use the difference as our anchor or our key to find out if we can add a certain number to the subsequence. Just like before, I will be having two pointers. One will run the iteration on all the elements, and the second will run the iteration between the first element and the first pointer. So when I'm pointing to element number 1 or index 1, the inner pointer will be pointing to all the elements before that, which is only 0. My first pointer is pointing to 1 and my inner pointer is pointing to index 0. The difference between the two is 0, and this is the first time that I have an entry with a 0 difference. So I will add it to the list and say how many pairs were there. So in this case, the number of combinations is only 1. So I will add 1 here. I will increment my outer pointer by 1. So now I am pointing to 2. So when I'm pointing to 2, I will be running the inner loop between the index 0 and index 1. When I'm pointing to index 0, the difference will be 1 minus 2 minus 1, and this will be 1 because so far I only have one pair with that result or with that difference. Now I incremented my pointer. This is also giving me a difference of minus 1, but I already have minus 1 in the list. The number of pairs that I can build so far is 1, 2 and 1, 2. I will be able to use both the ones before 2. So that's why I will increment my count of pairs against the difference minus 1 to 2. Now I will continue incrementing my pointer. Now I am pointing to 3. So when I'm pointing to 3, when I compare it with the first index, I will get minus 2 as my difference. When I increment my inner counter to point to the first index, I will get the same minus 2 as my difference. So I will increment my count of pairs here against minus 2 to 2. Now I am pointing to index 2. The difference between 2 and 3 is minus 1, and the number of pairs is 1. There's one more caveat that we need to think about when we are adding the pairs. If we encounter a difference between two numbers, and if the difference already exists in the first number, it means that we have already found a valid pair. If you look at the pairs for 2 with a difference of minus 1, there is already 1 and 2. So I can easily add 3 because the difference between 2 and 3 is minus 1 as well. So if I add 3 to it, it will still remain a valid subsequence. I hope you are able to follow me. Whenever the difference that we calculated already exists in the primary or in the inner pointer, we need to take that value, so which is 2 in this case, and add it to our answer. Right now we have two pairs which is valid, 1 2 3 and 1 2 3. Although it is same, but we are using two different values. One is index 0, one is index 1. Now that I know against the difference minus 1, I have two pairs already in the number 2. I will take that and add it to the list of combination for 3. So against minus 1, I will have two combinations for sure plus 1. Why I'm incrementing this number of pairs by 1 is along with 1, 2 and 3, I can also have a combination for 2 and 3. So this incrementing by 1 is pointing to the new pair that we just added, 2 and 3. Let's continue incrementing my pointer to 4. My difference between 4 and 1 is going to be minus 3. Pair count is 1. Between index 1 and 4, again it is minus 3. So I will increment current entry by 1. Now I'm pointing to 2. So difference is going to be minus 2 and 1 pair. every time I'm adding this value, I need to check if this difference already exists in the primary number. If it exists, then I need to take that value and add it here. So I will continue further. Now I am at 3, the 3 minus 4, the difference is minus 1. Minus 1 already exists for number 3. So I will take this 3 pair, add it to my result, which will be 2 plus 3. Because I am adding it to the current number as well, so I will do 3 plus 1 because I'm making a pair for 3 and 4 as well. The total pairs for minus 1 is going to be 4. All the pairs, it's going to be, I have added 4 to all of the pairs that we calculated for 3. Now let's increment our pointer and point to 5. So with 5 and the first number being 1, the difference is minus 4. The pairs count is going to be 1. Another 1, so I will increment it to 2. Now I'm pointing to 2. The difference is going to be minus 3. Check if minus 3 exists here. Against 2, it does not. So the pair count will be 1. The next is 3. The difference is minus 2. Check if this number exists here. It does exist here. So I will take its corresponding pair count, add it to my answer, and take this value and add it to the number of pairs. So it's going to be 2 plus 1, 3. So against minus 2, I have 3 pairs. I will do a check against 5 and 4. The difference is going to be minus 1. If there is a difference of minus 1 against 4, I do have it and its value is 4. So I will take this 4, add it to my answer. Along with that, this 4 will be added to the combination against minus 1 for 5. So the result is going to be 5. Now that the iteration is complete, all I need to do is sum up all the result that we calculated here and return it. So result is 11. We can build 11 combination with this input. I hope you were able to understand my approach. I tried to break it down into separate sub-problems and then solving it for each index and comparing it with the previous one. And whenever we encounter a common difference, the value that was previously calculated and incremented by 1. The time complexity for this solution is O of n square because we are running two loops, one inside each other, to iterate through all the combination to get the difference. And our space complexity is O of n square because we are maintaining the combination and the count for each index and referring to it to get the difference. Let me show you its equivalent C-sharp solution. Here is the equivalent C-sharp solution. In the main method, I am initializing a dictionary of integer and dictionary where the first key is going to be the index of the element in nums array and the other dictionary will have a key of difference and the number of pairs. From line 19 to 22, I am initializing all the entries depending on the number of inputs in the array. I start with having two loops running one inside each other. The outer loop is pointing the index starting from 1 and the inner loop is going to run against all the numbers between 0 and I. Then I calculate the difference between the two numbers and check if that difference is already calculated or not. If there is already a difference that was calculated, then I take the pairs or combos, add it to the combos variable, then I add it to the current pointer that I'm pointing at, the outer pointer basically. If that value exists in the previous or the primary number, I will take the combination that exists and increment it by 1. In case the combination does not exist, then the combos will be 0 and I will only be adding 1 to it. After this calculation is done, I take the number of combos that we extracted earlier and add it to the result variable. After both the iterations are complete, I will have all the possible combination results in this result variable and we return it as an output. I hope you were able to understand this C-sharp solution This is the exact equivalent implementation of the approach that we just discussed in a whiteboard session. If you have any questions or concerns, please feel free to reach out to me. Or if you have any feedback about my pattern or the approach that I took to solve it, I would be happy to hear it in your comments below. I will be adding the link to the source code in the description, so you can check that out as well. Thank you for watching this video, and I will see you in the next coding challenge. Happy coding!